Now we're talking about empirical formula and molecular formula. Let's begin with empirical formula. We can simply define the empirical formula as the simplest formula that expresses the ratios in which atoms appear in a compound. So you're having a compound, the formula that shows the simplest ratios in which these atoms of elements appear in that particular compound is called the empirical formula. Then number 2, we have this number 2, we have the molecular formula. Molecular formula can simply be defined as the formula that shows the actual number of atoms, in a compound. So the difference between the empirical formula and the molecular formula is that this one shows the ratios, whereas this one shows the actual number of the atoms in the compound. So examples of the empirical formula and the molecular formula, we're going to have the compound here, then you have the empirical formula, then lastly you have the molecular formula. So, number 1, we have water. The empirical formula for water, we have one hydrogen atom, we have 2 hydrogen atoms and 1 oxygen atom. The same time, the molecular formula for water is 2 hydrogen atoms and 1 oxygen atom. Example number 2, we have ammonia. We have 1 nitrogen atom and 3 hydrogen atoms. Same time here we have 1 nitrogen atom and 3 hydrogen atom. So the empirical formula is this, the molecular formula is that. Whereas for glucose, we have 1 carbon atom and 2 hydrogen atoms, then 1 oxygen atom. So the empirical formula for glucose, we have 1 carbon atom, 2 hydrogen atoms, and then 1 oxygen atom. So the molecular formula for glucose is C6H12 and O6. That is the molecular formula for glucose. When we look at benzene, formula for benzene is CH, that is the empirical formula. The molecular formula becomes multiplied by 6, you have C6H6. Then I can give you the 5th example. It is ethene. Ethene gas is CH2. That is the empirical formula. The molecular formula for ethene, you multiply it by 2, get C2H4. The difference here, this one just showing us the simplest ratios. So you cannot divide these ones anymore. Whereas here, we have the actual number of atoms. So that ethene has 2 carbon atoms and 4 hydrogen atoms in 1 mole of that particular compound. Now, it shows that the molecular formula is simply got from the empirical formula. So to get the molecular formula is equal to the empirical formula, then times n, where n is to be determined. Now for this case, look at this. The empirical formula here is H2O. So the value of n is 1. That's why we have this. The molecular formula, the empirical formula here is NH2. The value of n is also 1. That's why we have the same empirical and molecular formula. If you look at glucose, the empirical formula is CH2O. Molecular formula is C6H12O6. That means the value of n here was simply 6. When we multiply 6 into the brackets here, we get C6H12O6. Here also in benzene, the value of n was 6. Multiply 6 to get the molecular formula for benzene. And lastly, the value of n here was also 2. Multiply 2 to get C2H4. So we simply get the molecular formula from the empirical formula. Let us look at how we can find or we can determine the empirical formula of different compounds. And there are steps to take. So steps taken to find the empirical formula. Number 1, you write the symbols of elements. So write the symbols of elements in the compound. That is the first step. Number 2, you write the percentage. Write the percentage composition of the elements below them. Then number 3, you write the relative atomic masses of the elements again below. The elements again below the percentage composition. Then step number 4, you find the number of moles. Find the number of moles by dividing the percentage composition divided by the relative atomic mass. Then step 5, you find the simplest ratio by dividing by the smallest value. Dividing by smallest value. So simply, these are the 5 steps that we take. Write the symbol of the element, write the percentage composition of the elements, write the relative atomic mass under this, then find the number of moles by dividing percentage composition divided by the relative atomic mass. Lastly, the simplest ratio by dividing by the smallest value. We have our first example. Number 1, calculate the empirical formula of a compound which has 80% carbon and 20% hydrogen. Part B, if the molecular mass of that compound is 30 grams, find the molecular formula of the compound. Solution. We are going to go through our steps. Step number 1, we write the symbols of the elements. So we have the elements present. We have carbon. The symbol for carbon is C. Then we have hydrogen. That's how we write it. Number 2, write the percentage composition of the elements. So the percentage composition, carbon is 80, hydrogen is 20. So it's better we use the table, not to mix up with things. So I draw that. Having done that, the next step, number 3, write the RAM of the elements. Relative atomic mass. So the relative atomic mass of carbon is 12, hydrogen is 1. Step number 4, find the number of moles by dividing percentage composition over the RAM. So number of moles, divide percentage composition, which is 80, divided by 12. This one will give us 6.7. Then here we have 20, divided by 1, giving us 20. Then close that table. Then lastly, find the simplest ratio by dividing by the smallest value. The smallest value is 6.7. This is 6.7, this is 20. So we divide, so simplest ratio is equal to 6.7 divided by 6.7. This is 20 divided by 6.7. 6.7 divided by 6.7 gives us 1. 20 divided by 6.7, we shall get 2.98. We can simply round this one off by saying it becomes approximately 2, 3. Therefore, the empirical formula is equal to C. C has 1, then hydrogen has 3. But it is better not to write this one, so the empirical formula becomes CH3. That is part A. So part B, the molecular mass of that compound is 30 grams. Find the molecular formula. So if you are supposed to find the molecular formula, I told you, use our formula, like the empirical formula, times N is equal to the molecular mass. So the empirical formula in this case is CH3 times N is equal to 30. Then when we multiply, carbon is 12 times 1 times N plus hydrogen is 1 times 3 times N is equal to 30. This is 12 times 1 times N, that's 12N plus 3N is equal to 30. So 12N plus 3N, that is 15N is equal to 30. Then you divide by 15, we get our N is equal to 2. So we substitute our N here, so we have CH3 into N. When you substitute 2 here, I get C2H6. That is the molecular formula, molecular formula for that particular compound. It is C2H6. I have example 2 here. Calculate the empirical formula of a compound containing 28% of iron, 24% of sulfur, and the rest being oxygen. They are giving us iron 56, Am, sulfur 32, oxygen 16. So we're supposed to calculate the empirical formula. So following our steps, you first write the elements present. The elements, we have iron, have sulfur, then you have oxygen. Then, number 2, write the percentage composition. Iron, they give us, it is 28. Then sulfur is 24. Oxygen, they say the rest being oxygen. That means when you subtract 100 minus the sum of this, you get the percentage for oxygen. That gives us 100 minus 28 plus 24. This gives us 48. So 100 minus 52 giving us 48. Put in our table like that. And number 3, write the relative atomic masses here. Iron have 6, sulfur have 32, oxygen is 16. From there we find the number of moles, number of reacting moles. Get the number of moles, we divide the percentage composition divided by the relative atomic mass. So here, so we divide 28 over 56. This one gives us 0.5. Then divide 24 divided by 32. 24 over 32, you get 0.75. And lastly, 48 divided by 16. This one gives us 3. From there, you're supposed to find the mole ratio. Finding the mole ratio divided by the smallest value. In this case it is 0.5, so I divide 0.5 over 0.5, so it gives us 1. 0.75 divided by 0.5, this one gives us 1.5. Then lastly, 3 divided by 0.5, this one gives us 6. So, if at all we have a decimal point that is 0.5, we multiply the values by 2. So I'm going to multiply the whole of these values by 2. So as to remove the 0.5 and make it a whole number. So I'll get 2 here, I'll get 3 here, I'll get 4. Therefore, I'll get my empirical formula as iron 2, sulfur 3, then oxygen 12. As simple as that. But I can simplify this one more, adding sulfur plus oxygen, give us iron 2, sulfur, and oxygen. Divide this one by 3, here I get 4, by 3 I get 1, so I put the 3 outside here. Because when I multiply 3 times sulfur, I get 3 sulfur, 3 times oxygen, I get 12 oxygen, so it is the same thing. We have a third example. Calculate the empirical formula of a compound that contains 22 grams of zinc, 9.6 grams of carbon, and 38.4 grams of oxygen. Giving us zinc at 65, carbon 12, oxygen 16. Telling us if the molecular mass of the compound is 125 grams, determine the molecular formula. So, again, we go through the same procedures. Write our elements. Our elements we have zinc, carbon, lastly oxygen. Number 2, we have the percentage composition. But this time we have been given the masses, so let me put here mass. So I have zinc as 52 grams, then carbon is 9.6, that's the oxygen 38.4 grams of oxygen. From there, at the achieve atomic masses, this is zinc, it is 65, carbon it is 4, oxygen it is 16. Draw my table like that. Then, from there, I write the number of moles. Divide 52 by 65. This is 52 over 65. I get 0.8. 9.6 divided by 12. I'll get 0.8. 38.4 divided by 16. I get 2.4. From there, I divide by the smallest value, which gives us the mole ratio, where we divide by the smallest value, which is 0.8 over 4.8, gives us 1. 0.8 over 0.8, giving us 1. Then 2.4 over 0.8 gives me a 3. Then, therefore, the empirical formula is equal to zinc 1, carbon 1, then oxygen 3. Simply, I can write it as zinc, carbon, then oxygen 3. Simple as that. Then, telling us to find or determine the molecular formula if the molecular mass is 1.5 grams. Simply, what I can do is write the empirical formula times A, giving us the molecular mass, which is 1.5 grams. The empirical formula is ZnCO3 into value of N is equal to 1.5. Zinc is 65, times 1, then plus carbon, it is 12 times 1, plus oxygen is 16 times 3, into N is equal to 120, 125. Then from there, add 65 plus 12 plus 48 is equal to 125. This is into N. When you add up this, I get 125. N is equal to 125. Therefore, divided by 125, I get our N is equal to 1. Therefore, the molecular formula will be Zn CO3 into 1. When I put here a 1, I get Zn CO3. As simple as that.